Alright, last but not least, our fourth property is called the change of base property. Okay. This is actually the one that you'll use the least amount of times. It'll take me a little bit longer to explain each of the first three. So, change of base property, what it helps us do is first of all, it'll help us evaluate logarithms on a basic calculator. Some of the fancier ones you don't have to use this property, but on some of the just regular scientific calculators, you'll need this property. It'll also help us evaluate some logarithms by hand that look like they're really tricky to evaluate, but using this property we can change up how they look a little bit or make it a little bit easier. So here's what the change of base property says. It says if you have something like log base A of B, this can be rewritten as log base M of B divided by log base M of A. Okay. And the great thing about this property is you can pick whatever you want for M as long as you use the same base for M on the top of the fraction and the same base for M on the bottom of the fraction. Okay, so let me just show you real quick that this actually does work. Let's say we had something like log base 4 of 16. Okay. Well, we know off the top of our head that 4 to the second power is 16. So the answer to this logarithm is 2. Alright, we're using this property. What I can do is I can change this to having whatever common base on my logarithm that I want. I'll call that base M. Now, if I look at the number 4 and the number 16, I'm thinking that a good common base for my logarithms to use would be 2. So what I'm going to do here is I'm going to change this to being log base 2 on top and log base 2 on the bottom. And what goes up in the top argument is 16, and what goes in the bottom argument is the base that we had on our original logarithm, which in our case was 4. And if we do the math for this, log base 2 of 16, 2 to the 4th power is 16. Log base 2 of 4, 2 squared is 4, and 4 divided by 2 is 2. So we see this property works right off the bat. Okay. Now, I will put a problem like this on the test, and not always going to be quite that easy. Let's say you had something like log base 9 of 27. Okay. This was a little bit tricky because I don't know off the top of my head 9 to what power gives me 27. Okay. However, I do have a common base that I can use between 9 and 27, and that common base would be 3. So what you can do using the change of base property here is you can take this and you can make this log base 3 on the top and the bottom, but we can put the 27 up in the top logarithm, we can put the 9 in the bottom logarithm. Log base 3 of 27 is 3, and log base 3 of 9 is 2. So log base 9 of 27 ends up being 3 halves when we are done. Okay? So what this property allows us to do with just pencil and paper is it allows us to take a logarithm that might have a fractional answer, and we can figure out exactly what that fraction is by changing the base up just a little bit. Okay? Now, this also helps us work with a logarithm on a calculator. Okay? A basic calculator is only going to have 2 buttons that have logarithms. It is either going to have a button that looks like this, just says log, and if you guys remember from what we learned the other day, or at the beginning of class today if you watched the other video that I posted, if you just see a log button, it has an understood base of 10, and if you just see this button, it's ln. This has an understood base of the letter E. Okay. Remember, it's called the natural number. It's 2.71828. Alright, so let's say, for example, that we went back to that problem that we had, log base 9 of 27 that I just showed you. The answer to this is 3 halves. Let's see how we would evaluate this if we were working on a calculator. Okay. So if I pull the calculator up on the screen here, let's clear all this so you can see. Okay, so if I look at this, I got 2 different options for what I can use. Okay, because the calculator only has, as you can see, a log button here, which has an understood base of 10, or a natural log button here that has an understood base of e, the only two options that I can use if I'm going to try and evaluate this to show you is you can either type this in as log base 10 on top and bottom, you can put log of 27 divided by log of 9, or you could use the natural log on top and bottom. So two logs both have a base of e, with 27 on top and natural log of 9 on the bottom. So if we come over here and we look at the calculator, here's what I would type in: log, and again that has an understood base of 10, log of 27 divided by log of 9. If I see my answer here, I get 1.5, which is the same thing as 3/2. But just to show you how this property works, I could also try the natural log. And as long as I use the natural log for the top and the bottom, I should get the same answer, because that's what the change of base property tells us. So we could have the natural log of 27 divided by the natural log of 9. If I do this, I also get an answer of 1.5. Now we already said this is a problem that, although you could evaluate it on a calculator, you don't need to use a calculator to do that one, because we just showed you could just use as a common base on the top and the bottom a base of 3. So let's think about one that we couldn't do without using a calculator. So let's say you had something like log base 5 of 27. Okay. Now this one I can't use the change of base property for by hand, because there's no common base between 5 and 27. Like we had a common base for over here with 9 and 27, we used a common base of 3. Okay. Now we could estimate this, and if it's not obvious to you how to estimate this, think about it like this: 5 to the first power is 5. 5 to the second power is 25, and 5 to the third power is 125. Okay. So I'm guessing that log base 5 of 27 lies in between 25 and 125. So if I had to guess, I'm going to guess that this is a little bit bigger than 2. It has to be somewhere in between 2 and 3, because the answer to a logarithm is an exponent. So it has to be a little bit bigger than 2, and it has to be less than 3. I'm going to guess that it maybe is like 2.1-ish. Okay, so I could I could estimate that, but the only way that I'm going to actually be able to figure out exactly what this is to go over here and plug it in on the calculator. So I might try on the calculator log base 27 divided by log base 5, or I could try the natural log of 27 divided by the natural log of 5. Okay, and if I come over here on the calculator and plug this in, I could write this as log base 27 divided by log base 5. And remember, we're expecting to get an answer that's a little bit bigger than 2. If we do it, we get 2.05. And then also, if we wanted to check it the other way, we could also try the natural log of 27 divided by the natural log of 5, which should give us the exact same answer of about 2.05. Okay, so here we're seeing how the change of base property works. It allows us, if we can find a common base, to do this by hand, or if we can't find a common base, like on this example, we would have to do it using a calculator. Okay?